this episode, John Langton talks about his journey in creating a data science startup and discussing the future of enterprise AI. So stay tuned. Welcome everyone to another episode of Future of Data Leadership Podcast. Today we have with us John Langton from athenahealth. A quick bio. John Langton is Director of Data Science at athenahealth. He was previously CEO of VisiTrend, a visual analytics company that was acquired by Carbon Black in 2015. He has a Ph.D. in computer science and an extensive background in AI, machine learning, big data analytics, and visualization. Prior to founding VisiTrend, John was Principal Investigator on several DoD projects at Charles River Analytics. He has taught classes at Brandeis University and has several peer-reviewed publications. With that, so John, thank you so much for agreeing to come to the podcast and sharing your insights with our community.
Sure. Thanks so much for inviting me. I appreciate it.
So why don't we start with your journey? And I think it's fascinating. When I was looking at your LinkedIn profile, you are one of those guys who have worked through the startup phase and brought up a AI and machine learning startup, get an exit from that, and then helping athenahealth. So why don't you walk us through your professional journey to give us a taste of what you have been through? We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast.
Sure. Yeah. It was certainly an interesting journey. I tend to color a little bit outside the lines. So it started off traditional enough. I got a Ph.D., so a very academic background, specializing in AI, machine learning, and visualization. I was particularly interested in the sort of intersection of human intelligence and machine intelligence. So can we use humans as sort of feedback functions and evolutionary algorithms as the fitness function, things like that, and how do we sort of pair what humans are good at and what machines are good at, and sort of human in the loop analysis, things like that. I did sort of some early work with computational neuroscience and developed a tool for them to sort of explore parameter spaces of neuron models. And from there, my first real job was at Charles River Analytics. And then I went just deeper into artificial intelligence, machine learning, worked on a bunch of Department of Defense projects. So some of them were using evolutionary algorithms for routing multiple unmanned aerial vehicles and sort of multiple objective optimization, things like that. And that's also where I started to get into cybersecurity. So I was really interested in using more advanced techniques. I think in a lot of fields, and especially cybersecurity, they were trying to get a handle on just securing things at all. It's pretty hard to get traction. And so a lot of the initial systems were rules. Humans were kind of like doing analysis. They'd figure out what would happen and then would make a rule that would say, if this happens, stop it or fix it or respond in this way. And I was interested in using much more adaptable, flexible, autonomous techniques. So probabilistic algorithms, AI, machine learning, things like that. And so I started getting into that, and I was very early in that space. I think, in all honesty, only now is the cybersecurity industry really starting to mature in those aspects. And you have some companies doing interesting things, Carbon Black being one of them. Sometimes they call it behavioral analytics. But that was something I started working on actually on an Air Force contract, and sort of had the entrepreneurial bug bite me. And so I left Charles River Analytics and started my own company. I knew the sort of contracting space, and so I bootstrapped the company at first with other contracts, proposals, and contracts that I won with the Department of Defense. But from there, after sort of writing the original software, I wanted to pivot and commercialize it within the private sector. And so I was actually successful at doing that, which I was really happy about, because a lot of folks have difficulty bridging that divide between the actual DoD work and then commercializing what you produce in the private sector. And so I raised money through venture capital. There was a VC group called Atlas Venture at the time. Since then, it's split up and it's become Accomplice Venture in another group. I think they actually retain the original name. But I was working with a VC named Chris Lynch, who has since actually left Accomplice, and he's now doing kind of his own thing. Really interesting guy. Tons of fun to work with. Had a great experience with him. You know, we developed the company, developed the technology, learned a lot of lessons, did a lot of things wrong, but luckily had a profitable exit, good exit for everyone. And so that's wonderful if you can do that and have a great learning experience and still walk away from it. So Carbon Black acquired the company because they were interested. We were actually a more general platform. The vision was really that original insight I had during grad school of trying to do human in the loop analysis, lower the bar for people to do data science and machine learning. Essentially, the concept was that we would really work through visualization, interactive visualization, sort of show users their parameter space of the problem that they were trying to solve, and then enable them to interact with the visualization to run algorithms, you know, like auto-regressive integrated moving averages, but they would have no idea. So when they're drawing a line graph, they might be doing this crazy forecasting, but they have no idea that's what's behind the scenes. So we're really trying to make it really intuitive so that they're just interacting with the visualization, but it's doing, you know, tapping into these really powerful algorithms. And so that could be applied to multiple different spaces. We actually looked at, you know, marketing optimization. We were working with a company that was doing AdWord optimization, AdWord choices. We actually did some fraud detection with an insurance company. And then we were doing, actually working with a high frequency trading company, doing multiple things there. And ultimately we were looking a lot at cybersecurity, and that's what interested Carbon Black. So how do you apply these advanced algorithms to cybersecurity? Because like I said, cybersecurity, you know, started as out as rules, and even the sort of the antivirus approaches are really to sort of hash a file, and if a new file comes on your system and it matches, if you hash it and it matches this hash of known bad things, then block it. The problem is that there are literally hundreds of thousands of new malware, you know, coming on to the network every or the, you know, the internet at large every week. So, and if you've never seen something before, you know, you can't respond if you're only looking for a hash of known bad things. And so the techniques folks were using after that, I mean, this is a very well-known thing within the industry. So people would develop techniques of looking for specific behaviors. So they'd make these rules that, you know, if something, you know, tries to access memory space that it clearly should not be accessing, then say it's a bad thing. Or if a file actually has 0 size, you know, that's an indicator. So there's all kinds of sort of indicators. The problem is it's still very brittle because there's still rules, and the behavior, you know, the hackers will figure out how you're detecting them, and then they'll slightly change their behavior in order to avoid detection. And so what we were doing is applying machine learning methods to basically be able to see patterns across these different behaviors. So rather than create a rule that detects one specific behavior, we're learning general rules through machine intelligence, things that are probably non-intuitive to a human that you wouldn't think of to create as a rule, but that the machines can see as patterns of behavior that these types of files do, and then detect those. So patterns of attack. And we actually had a lot of great success there, and some of that technology is being used in Carbon Black's offerings. So they've got some really interesting stuff for behavioral analytics, malware detection, things like that. And from there, there was a successful transition, integrating the technology, applying the technology for new problems at Carbon Black. And then I actually was contacted by athenahealth. So I'm regularly contacted by various companies, interested in doing stuff. But the call with athenahealth was very interesting to me because the healthcare industry just seems so ripe with opportunities for applying advanced algorithms, advanced techniques. And of course you see a lot in like industry conferences and various things, how, healthcare AI is like really hot. And other people are realizing this. It's basically a green field of opportunity. There's I think healthcare in general has been very slow to adopt new technologies. And so it's, there's still a transition to electronic medical records. A lot of folks are still making that transition and figuring out what systems to use. Of course, athenahealth provides, their version of that. And so once you have all this information digitized, you now have access to it, and you can apply various algorithms to it. So, there's definitely lots of complications. The data is very messy. It's highly diverse in structure. So you have, doctor's notes, free text notes, and a lot of the time it's not natural language. It's, sort of snippets of thoughts, they're just kind of like jotting things down. And so a lot of like traditional NLP techniques that are looking for sentence structure and trying to root out semantics won't work because, these are just like sentence fragments and weird things like that. And so you have to use different types of NLP approaches to try to get information out of things like that. And then there's structured aspects to the data. There's fields, of course, the name, age, and all kinds of, measurements that are taken on patients. And so there's a real challenge to get all of that data into a format where you can apply algorithms and do interesting things. But I enjoy that challenge. And so there's a lot of exciting things that we're doing at athenahealth, applying AI and machine learning.
And thank you so much, John, for walking us through your journey. So, what's your current role in Athena? Like, what are you responsible for? So, director of data science. What does it really mean? If you can shed some light on that.
Sure. So I am the director of data science, and that can mean different things at different companies. I actually have a fairly large team. It's around 25 people, and I think we just added several people, so it's getting up to close to 30 people. And that is broken into different teams, primarily 3 different teams, and each of those teams has a manager. And then there's a senior manager who helps me more on the operational side, sort of executing things, where I view my role is more strategy. So I definitely wear many hats. So I have a very deep technical background, which I think sets me apart from a lot of managers. So I've done quite a lot of coding myself. I like coding. So I'm hopefully not too annoying of a manager where I will actually have opinions on how to do things, and I will make them known. But yeah, because of that deep technical expertise, I can serve as a foundation for the rest of the entire organization. If folks are wondering what algorithm, if they're encountering a new problem and they're trying to figure out what is the selection of algorithms I should be considering to solve this particular problem. A lot of the time they come to me and they ask, and so I'm really sort of laying the groundwork, creating the project roadmaps for very large, ambitious projects. I'll come up with that project roadmap, talk about the algorithms, what order they should try them in, how they should evaluate them, what they should be anticipating, things like that. I'll provide a lot of feedback and guidance on projects, things like that. So in one aspect, I serve as an architect for building these large big data systems. I also interface with a lot of other organizations around the company. So sorry, I'm bouncing all over. Part of the vision aspect is trying to figure out what the department works on. And when I joined athenahealth, I was given a mandate essentially that traditionally the data science department had done much more tasks along the lines of traditional business analytics. So sort of like if a product metric goes up or goes down, can you figure out what variable is correlated with that? Like if users are taking longer to complete this task, do we get more calls in the support center? And so it was very traditional business analytics, and they really wanted to transition from doing stuff like that to taking on more advanced analytics projects, using AI, using machine learning, and then even becoming a center of product themselves, creating new product. And so that was really my sort of my mission, was to transform.
Interesting.
Yeah.
So I think if we talk about your journey, right? So you have worked on a service industry, then you worked on your own startup, raised it to success. Then you move to a big corporate entity. Like, what are some of the similarities that you have seen as someone executing data science or AI, or and like what are some of the things that you call recipe of success when you are sort of translating between different corporate structures to deliver an outcome? So if you can shed some light on that.
Right. That's a really interesting.
We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast.
Question. I hope I have a good answer for you. I mean, the keys to success, I mean, it depends on like what aspects of success you're referring to. I mean, there's like building teams versus success on the projects versus success in your personal career. I mean, I think the first thing that pops in mind, which maybe is a little ephemeral, is trying to get at what, really trying to lock down what the goals are, what the objectives are. And that can mean different things. So in the DoD contracting, it was sort of, everyone has sort of like the different perspectives on techniques, and when you're writing proposals, you have to sort of infer what is the problem the person's really trying to solve. So being able to drill down on what is the actual business problem, and that was true in the DoD side of things, when you're trying to basically address a problem, understand the problem that they're trying to address, and then solve it, and be able to respond to it in a way in your proposals that resonate with the people who are essentially evaluating proposals and deciding whether to give you money or not. The same thing holds true. There's a vein of that certainly in a startup. Figuring out the business problem. What business problem are you solving? I think a lot of folks, some really business one-on-one mistakes folks make are they think about the technology first. They think, hey, I have a new idea for a new technology, and I think it's really neat. So I'm going to build it, and then I'm going to go figure out what business problem it solves. And that is the exact wrong thing to do. You first you have to figure out what is the business problem that you're trying to solve. And unfortunately for tech folks, a lot of the time the solution is not necessarily elegant. To get there first, you know, do minimum viable product, and to try to going with all the business concerns that you have when you're trying to keep the lights on. Technical elegance is at the very bottom of the priority list, and the initial solutions are not necessarily the best solutions. And in the marketplace, the best solutions don't always win out. In fact, very often they do not win out. And I think like actually, I don't. This is a bad reference to make, but I think VHS and Betamax is an example people throw out there. I probably shouldn't throw it out there because I don't know anything about the technology, but folks had argued one is better than the other, but because of business relationships or other issues. But anyway, and that is certainly true with athenahealth. When you have to justify your department size. You know, what are you doing? What is the output of your department? You know, leaders in companies want to know this, and so you have to justify your existence, really, and especially if you want to grow and increase your influence at the company. And so one of the big things that I do at athenahealth is that I go from, they have multiple products, and so I go from product owner to product owner, work with leadership on the product side, product management, and I identify, you know, what are the business problems that they're trying to solve. And it's an interesting question, because a lot of the time when you enter these conversations with folks, they'll start thinking in terms of, what can AI do for me? Or what can machine learning do for me? What can data science do for me? And I really don't want them thinking about that. I want them telling me, what is the problem you're trying to solve? It's really my job to figure out how data science will go through and solve that. And to tie back to the original answer, and the theme of what I'm trying to communicate is that what I will often see are folks in data science sort of go down rabbit holes. You know, I have a wonderful colleague, employee that reports directly to me, has incredibly deep expertise, postdoc from Harvard, and he's incredibly knowledgeable, but he gets so sort of wrapped up in solving a technical problem that, and this goes even on the technical side, even if you're not considering the business problem you're trying to solve, but really keeping your eye on the ball, as it were, and making sure you're really focusing on solving the problem at hand and not overcomplicating your solution. You know, so we have a natural language processing problem we're working on, and so he's looking at, you know, named entity extraction, and so he's like pulling down all these libraries, these Python libraries, plugging them in, and like doing all these things. And the reality is that this one part of the problem can very, very easily be solved with regular expressions. You know, so starting with the most simple thing first, I think is key. You know, keeping an eye on what is the problem you're actually trying to solve. Don't get lost, or don't basically listen to the siren songs of advanced techniques. You know, I mean, it's perfectly fine to be passionate. You know, I very much encourage that, and want to learn new things and try new things if it fits in. But you can very easily go down rabbit holes, and as a consequence, fail to solve the actual problem you're trying to solve. I guess in a way, I'm trying to get at the point that there is a really big difference between academic data science and applied data science. And if you want to be in academia, then ignore everything I just said. But if you want to, if you want to start a company, or if you want to work at a large company and be effective, then you know, the applied aspect is really the key to success. It's the ability to translate from what an algorithm does or what an approach does and fitting it to the real world. And how would you apply that? How would you evaluate it? How do you translate that? Because there's very rarely a very clean one-to-one mapping. And a lot of the time what I find is very much most, I'd say 90% of folks, the employees that I work with, if not more, probably 95% of folks can academically know how to solve a problem and counter a problem in the real world. And when they look at it in the real world, have no idea that this is that type of problem and that this is how you would solve it. They can't make that mapping or figure out how to format the data from the real world in a way that you can apply an algorithm. So being able to bridge that divide, that's really probably the biggest value, certainly one of the biggest value adds I have. And one of the things that has made me so successful and why I'm a director of data science is my ability to do that. And ultimately I do that on projects. And that's why I'm sort of creating the project roadmaps and helping people.
I think that's interesting, John, by the way. And it reminded me of one of the conversation I had with one of the data science executive at one of the largest insurance company. And she put it the best. She said, Vishal, the problem with data science is there's a lot more solution than there are problems. And so and if you don't have a problem to a solution, then it's a noise, right? So now it's your job as a leader to sort of not let your team distract on a lot of solutions that doesn't correspond to a particular problem. So I think you nailed it fair and square, that getting to the problem is the heart of putting together any successful team or group or whatever. So thank you so much for sharing that. Now let's talk about your entrepreneurial journey a bit. So what are some of the migraines or some of the headaches that you used to face sort of when you're putting together this company, VisiTrends, and if you can shed some light on some of the challenges that you saw in putting together a data science sort of AI-related company.
At a startup company, the challenges there are definitely distinct from the challenges at a larger company. I mean, I think when you're building a data science team, there are definitely general challenges that I think apply across the board. Trying to actually do a startup presents its own set of challenges. One big difference is that we're trying to sell product. I think data science at companies a lot of the time are internal facing. athenahealth is actually an exception. We are actually creating product that is customer facing in addition to being internal facing. And so we have both internal and external stakeholders. And that's fun and exciting and very different. I think most data science departments at companies are internal facing. And so you're trying to help someone else, figure something out. Like you might be working with UX teams to do A/B testing, sort of figure out, is a new feature or a new website design, good? Is it going to result in more traffic, more people purchasing more? Or you might be optimizing marketing, or you might be optimizing, for Amazon or Wayfair, optimizing sort of delivery of furniture and like how much furniture of what type do you store in what locations and what warehouses to make sure you're able to deliver everything within 2 days, So optimizing distribution and all those sort of things. It's all internal facing. So you're not trying to go and sell that to someone. You're not trying to say, hey, this is, in some cases, depending on company politics, you might be trying to do that to internal stakeholder, but you're not, trying to convince someone that, hey, you should buy this product. At a startup, you are. So one of the biggest challenges, there were a lot of challenges. One of the biggest challenges was educating the customer. When you're trying to sell an advanced product that is using AI, machine learning, and it doesn't even have to use those things. Really, any advanced product, I think, that doesn't have a very accessible story, it is very difficult. You have to figure out what resonates with customers, and a lot of the time, you might hear this in more and more businessy meetings, if you start going up the management chain or whatever, people will start, asking, so who cares, but, so it accomplishes this technological task. Why do I care? And then they'll just keep on asking that. So you'll say, well, that will enable you to, ship widgets within 2 days. And then they'll keep asking it, well, so what? Who cares? And it's like, well, that results in customers being happy, and then they buy more product. And so you really have to get it back to, at the end of the day, dollars and cents. Does that generate more revenue, or does that reduce costs? Why do I care about this thing? That whatever it achieves technologically is not good enough. So if you can craft your message to really hit those things, it will resonate with customers, but they still want to know the how. So that will at least open their ears and get them to listen to you. But they still want to know the how. And if you have a complicated story, it is incredibly difficult to educate customers to what your product does. So this was certainly true for VisiTrend. The other thing is we were essentially trying to lower the bar for people doing advanced analytics. And so this means that we had broad use cases. So as I mentioned, we with some clients in marketing, insurance, cybersecurity. It is, I would say in general, it is very inadvisable for someone to start a company and try to have such a broad market that they're trying to address. And so that was a mistake that we made. And so what you really want to do is sort of attack a single vertical, try to narrow the scope. And part of this is also simplifying your message. So for instance, there was another company that was using a finite set of only a handful of analytics to analyze DNS traffic and visualize it. And they got much further. And this is something that we did out of the box. This is like something that was very, very easy for us. And we had many more analytics run on DNS traffic and many other types of traffic. But because their message was so crisp and so clear, even though they had less functionality, but their message was so crisp and clear, this is what we do, this is all we do, and we do it well. They actually got further and farther than we did. I guess you can, thinking of strange analogies, like Chipotle, they don't have a lot of options, it's sort of, burritos or a burrito bowl, there's very few options, you can mix and match them. But that for them, it's like economies of scale, and they can scale, they don't have complexities of creating these different things. The same thing kind of applies in a startup. The more analytics you're trying to support, the more time that you're writing all this code without knowing how is it going to actually be applied and, by a customer. So you really want to identify that vertical, sort of go after it. And that's a challenge in startup that is unique. And again, that sort of education phase. I mean, so we were hitting cybersecurity. I'll relate one last story on that note. We were doing analytics to show and visualization to show how you can detect different things in cybersecurity. It's something called hunting now. That's the other thing, is we were early to the market. You can actually be too early to a market. You can have a solution and a product, and I think we actually happened upon that because hunting was not a term in cybersecurity when we were around. And it has since become a term, and there's many requirements for products that do what we did now that were not around before because the market hadn't caught up yet. And this is basically around humans that are trying to do incident response, trying to figure out, once you've been hacked or you had some sort of incident, what actually happened, how did they get in, did you clean it all up, did you do everything, do they still have access, and how do you respond to it? And so they're essentially hunting, or also just trying to detect what actually happened, did something happen? So they're hunting through like all of these different computer logs and trying to find information. And part of our huge value add was being able to sift through massive amounts of data very quickly and identify patterns and show them to you visually. And so the demo that I ran to do this was DNS tunneling. And so this is a way of doing data exploration. So basically, someone in your organization who's a hacker and who's very, very skilled can use a technique where they establish a tunnel with an external server, and they basically sneak information out of your company inside of DNS requests, inside of some of the header values, and they can encrypt it so nothing actually sees the data going out. And the way that it's going out is it looks like they're just requesting websites. So most security stuff doesn't detect it because they don't know, is this a valid website or is it an invalid website? You know, it's just someone's going to, you know, google.com, only now it looks like, you know, XXY, you know, basically code.com. And so I was showing how you could detect this with our technology. And I was going over all this fancy technical explanation of how we were doing this and how neat it was. And at the end of it, I realized, and I was talking to a CISO, and this is supposed to be someone who knows a lot about security, who like controls the security for an organization. And this was in particular over a company that was worth several $1 billion. And this was the guy in charge of all of their security. At the end of my spiel, I realized he had no idea what I was talking about or what DNS tunneling was. And so that was all wasted time. And so that goes to show that, you know, educating the customer about data science, that's unique to a startup. If your product is a data science product, educating the customer and then, you know, showing them, you know, ultimately the only thing people care about is what does it do for me? And so it's better not to even enter those conversations until someone really asks. And most of the time they'll stop you once you start explaining, but you know, tell them what it does, just like it stops data exfiltration. It's tough because then they want validation that you're actually capable of doing that. And if you're a startup, it's harder because, you know, you're a small company, they're not sure to trust you. You actually say, so you can start talking about technical stuff, but then they don't really want to hear the technical stuff. So it can be a very difficult position to be in. At the end of the day, I find whether you're at a big company or a small company that results always win. And so if you can, some problems and the results are not always clear, and communicating them and communicating how you've been effective are not always clear. But most of the time they are. You know, there was actually a lot of political nonsense that I dealt with recently on a very large project that I was working on, which was automatically classifying medical documents. And the thing that really kind of solved it for everyone was that the models that I helped engineer and that my team took on just trounced everything else, outperformed everything. And so at the end of the day, it was like, hey, man, you know, this works. So, you know, and that kind of ended all the arguments.
Interesting.
Yeah.
Interesting. So I think one thing that definitely I want your perspective, and this is something that we hear a lot about from many of the innovative entrepreneurs in our community. So data science is very new, and everyone comes with their distinct model to approach a particular problem. As we said, there's a lot more solution than there are problem in the world in data science. So now I call it like who the hell are you syndrome. Right. So when a startup comes, and you laid out some element in it that, hey, being innovative, now it's your job to teach someone, but why the hell someone care unless you're just talking about their bottom line or how it's either optimizing the operations or increasing the revenue. It's all noise to most of those guys. What are some of your hacks, if you can shed some light, that really helped you through getting yourself in front of those conversations? Many times that you were new and you were sort of coming up with a startup with an innovative idea with not probably a good brand backing you up initially, and so yeah, what are some of your cheat sheet if you can shed some light?
We'll
resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast.
Traction with a potential customer?
Yeah.
Well, so some of them are probably pretty obvious, but maybe not. First is make sure you're solving a problem they have, right? So we talked about that a bit. So definitely make sure that they have a problem. And so depending on like how salesperson-y you want to be, there's sort of a way to negotiate and navigate conversations where you're trying to essentially assess what problems they have, while at the same time saying that you solve the problems that they have. And so there's a bit of a dance there where you're trying to get that information, because you can't say, obviously you need to know what problems they have in order to say that you solve them. But at the same time, trying to say that you have the capability of solving them with your technology. At the same time, I would definitely caution anyone: you actually don't want, even if you could win a customer, sometimes you don't necessarily want them. And that might sound really odd, but if you have a customer that's going to require you to customize your software, your solution specifically for them in order for you to deliver on what you sold them, you have to think about the cost of the technical debt taking on to do that customization for them, and will that customization work for other customers? Is it generalizable? Is it taking away from your ability to address other customer needs? And so you want to be careful about that. That's one thing. The other thing is try to address, especially if you're a startup, pick a really good problem, pick a really hard problem. Provided that you have an idea of how to solve it. Something that really resonates with people. Something, being timely is certainly a good idea. At the same time, you don't want to chase trends. So you just try to keep a balance there. And there, if you can consider, if the solution is elegant in that it's short, that if you can describe it in an analogy. I'm actually working on another startup now, and part of the big reason why I find the idea very compelling. Obviously, it's my idea, so I'm biased. But is that I can sort of throw out an analogy from another business domain to describe. I'd love to share it with you now, but I'm thinking my VC would probably be upset with me if I shared it very early on. But very early on, but it's a very clear, crisp idea. I can communicate it in one sentence. And the reason I can do that is because there's another solution in another industry that solves it. It's a different problem, but it's an analogy. If you can use an analogy to really, something that someone's really familiar with. I'm trying to think of an analogy like I'm talking about, but I'm blanking. But being able to really communicate things clearly, and then from there, it's really relationships. I mean, and credibility. I mean, the one thing there's definitely pros and cons. I think because I'm a very, very technical person and I have an extremely strong technical background, people who work with me, are very kind, and I think, I've delivered some incredibly effective, incredibly complex solutions. I've worked on massive data problems. I've created data processing pipelines, with different cloud infrastructures, using containers and sort of architected these complete solutions of delivering advanced algorithms in the field for, real product. This is stuff that people are still pushing on now, and I've actually, cut my teeth and I have experience doing it. So I have this extremely strong technical background, but that can actually be a detriment to business folks. Folks are get very scared when they hear a technical person talking about product management and what you should be doing for a product, and rightly so, because most technical people don't know that stuff. Most technical people think about what, a lot of them are idealists, a lot of them are purists. This is what we should do. We should program our product in Haskell because it's the real programming language. These are the types of things technical people say and think about. Whereas a product manager is trying to figure out, what did the customer say? What did they mean by that? What do they actually want? And a lot of time technical people don't care as much about that. They want to tell the customer what they want. And that is very, very wrong. That's the wrong way to go about things. So because of my technical background, I think a lot of the VCs included, I can walk into a VC, and because of my PhD and my background and my resume, they love me, right? But they're like, okay, who's the business guy? So in a startup team, typically, and I would recommend most people, I think they're right. You want a technical guy and a woman, and a business person. And doing like a startup on your own, I actually did that with VisiTrend. Not advisable. It's very, very difficult. Most people cannot do it. Most people can't do a startup with multiple people. Doing it with one person as the founder, wearing all hats, is a Herculean task and very difficult. But back to the point that having this technical background, people might not think I have the business chops. I think that's changed now just because of my experience and what I've done in my various roles and capacities and so forth. In fact, right now I'm looking at product management roles, which is a very new, interesting thing for me. But also on the VC side, I think folks don't realize that I have insights there. But yeah, so a lot of unique challenges, on the startup side. Sorry, I think I lost the thread.
No, that's fine. So let's talk about one thing that I need your perspective on is good hires, right? So in your journey, like what are some of the traits of hires that you love? Like what are some of the traits that you see, hey, if you have those or at least acquire those, you'll be a preferred candidate as per what you want to hire for your teams.
Right. Well, I think this is very challenging for companies because there's a really high demand for qualified folks. At the same time, there are a lot of programs that have seen this demand, and so now there's this cottage industry of people trying to train up data scientists, and so people take a Coursera course and then call themselves a data scientist, and not to cast aspersions, but there can be a vast difference between candidates, and it can be very difficult to identify which ones are good. And now there's a glut of people calling themselves data scientists. They're seeing this trend, and they're not really data scientists. You will see, some of the trends that I see too are companies will hire someone like with a physics PhD and okay, now do data science because it's like the closest thing that they can find. There's not necessarily anything wrong with that, but in order to do something like that and have it be successful, you still need that initial candidate or the director, such as myself, who has a really deep expertise and broad expertise, who's a generalist, who can support the growth of a team that doesn't necessarily have a core data science background. And I think in the current climate, that's what you have to do. The initial hire, you really want to be an expert. You want to try it, and you're going to have to pay for it, and you just got to suck it up and do it. Get an expert, pay for the expert. From there, the additional folks, can be more junior folks, or they can be quantitative folks. And so what I look for in a candidate are people with aptitude. I don't necessarily look for a specific class that they took or a specific thing. I mean, that certainly helps, if you know R, if you know scikit-learn. actually written code before. I mean, these are things that I look for and help. But I'm really looking for aptitude, the ability to learn these new skills, and the interest in learning new skills, and then I look for a quantitative ability background. So a PhD in physics is actually perfect. That's great. I actually have a postdoc in physics that's working for me, and he's a great employee, very effective. But he does lack sort of the context of what algorithms do what, when to use them, and these things. But this is stuff that I can help train them on. And so I actually established a training program for actually the 30-person data science team, but I've opened it up to the wider company of I think it's like 6,000 people now. So that anyone interested, could check it out. And for me, I'm kind of a formalist in some ways, and so the initial courses, I'm going over core statistics. And a lot of people are doing core analysis, but they don't even know what it is. They don't know the different techniques that are available. So even going through, basic regression, and Pearson's correlation, things like that, and making sure that people have a real intuition for it. And that's key for me. Like I don't want to memorize math and then be able to rattle it back or do it on paper. I want them to have an intuition for how these things work. And so I'm going through this training curriculum, and part of it is machine learning. So as long as the person has aptitude, this is really the main thing I look for. From there, they can be trained up. But if you're creating a new department, you do need that person who has the capability to train up the other folks. Yeah.
Interesting. So thank you so much, by the way, for sharing your thought on the ideal candidates. One more area where we almost at the tail end of the conversation, but I still want to capture your thoughts on is your background in AI, right? So
yeah,
you are very well versed in it. You have worked in various. You have your own startup in that area. You've worked with various enterprise segments in that domain. So what are the and you briefly mentioned in this conversation as well that so how mature is the enterprise AI compared to lab AI or educational AI? Like what are some of the gaps that you're seeing that is like how much of your data science is actually AI, and if you can shed some connection between the enterprise data science and its usage of AI, that would help us understand what businesses are thinking when we talk about AI.
Sure. Yeah, I mean, there's been some really interesting trends in AI because so I have done a lot of research in AI, and AI has had multiple winters where it was basically a bad word, and it's supposed to say AI, and so it's very interesting to see in the market it coming back again. It seems to have many lives, and now it's all over the place. You're seeing AI everywhere. The reality is that even during the winters, new technologies were coming out, and it's a lot of very effective things. People are carrying AI around with them every day. Pockets, the phones have AI in them all over the place. Elevators have AI in them now to basically to predict what floors they should be at based on traffic patterns. So in large skyscrapers, the elevators themselves have AI. I mean, rice cookers have AI. They have fuzzy logic that came out of AI. People don't realize this because it's interesting. Once something in AI becomes useful, people stop calling it AI. And I think the divide is that when you hear about AI, I think people think of things like Star Trek Data, the Data character, a walking, talking robot that can think like a person, like a human. And that's what people call general AI or strong AI. Right. And so when people, it's very romantic, and AI becomes very interesting and compelling to people because of that sort of impression of AI. And then when it does not result in a walking, talking robot that you can't tell the difference between that and a human, then people get really jaded and like, oh, AI doesn't work. The reality is that AI is sort of I consider it a tool set. There's a lot of great tools that it provides to solve different problems. And even during the winters when you couldn't get funding for AI research, it was producing great tools like fuzzy logic that we use every day. Fuzzy logic is being used in gearboxes for cars, so it's definitely has applications. And I think it, at Athena, we are different, probably because of me, in that we apply a lot of advanced techniques. We apply AI, we apply machine learning. A lot of data science departments don't do that. A lot of them are making forays into machine learning, but a lot of them are still sort of only peeking into AI. And to be clear about that too, is I think because I think there's a lot of confusion and conflation about topics. Machine learning is AI. It is a subset of AI. And so is natural language processing. So AI is basically an umbrella term for a lot of different approaches, a lot of different techniques. Certain groups of them have become more popular because they've been effective. So neural networks, like convolutional or recurrent neural networks were around in the 60s. And people are talking about them now because, Google has TensorFlow, and deep learning is becoming this huge thing. It's been around for for many decades. I think what's changing now is that you have access to way more data is digitized. So there's a lot more that you can apply these algorithms to, but also hardware and computational abilities, computational capacities are at an astonishing scale now. So you have Google creating things like the TensorFlow processing unit, the GPU, and GPUs being used for things. So basically neural networks, even though the technology is quite old, the application or the ability to apply it to interesting problems effectively is very new with the hardware. So you're seeing a lot of trends that are going to continue to evolve over time, where data science, AI basically infiltrates data science more and more and more. And it also changes the way that we're doing data science. So to answer one aspect of your question, I think industry is still very lagging behind academia. Academia is way, many decades ahead of what's actually used in industry. And that's always been an interesting relationship to me. It's far out. So there's solutions for interesting problems now sitting in, books, waiting for someone to actually apply them, which, is great for me because that's what I do. But yeah, AI has also changed the way we do data science. There's been some interesting developments. There's actually something called the data science machine that came out of CSAIL at MIT. And they essentially used AI to do feature engineering and modeling, and they had it compete in these KDD competitions, and it actually beat out a lot of human teams. And so it's fundamentally changing the way we do data science. So I think you're going to see AI I don't want to say encroach because I don't want people to be afraid of AI, but it certainly changes the way that we work with data and the way that we do data science. I think you're going to find, parameter optimization for your machine learning algorithms, with algorithms such as, gradient boosting machines or random forests, you have, parameters such as, what's the learning rate, what is the depth of the trees that you're learning, how many trees do you learn, and do you set that according to the sort of loss function that you're using.
Interesting.
So you can use AI essentially to do what you're essentially doing is applying AI on top of AI on top of AI. So you use AI to optimize those parameters by turning that into another AI problem and the gradient descent problem. And I think that's really, you're going to see a lot of that. So data science is going to change fundamentally, and you're going to see more and more packages out there that do a lot of this stuff automatically. It's still not going to replace the human intuition for feature engineering. It's still not going to replace the human intuition for what algorithms to use to solve what problems. But it's going to solve a lot of problems, a lot of very basic things. out of the box, that are generalizable enough. There's a lot of stuff that's not generalizable though. So
interesting.
So there'll be new techniques that we'll be using.
Interesting. Why don't we hear your closing remark for anyone following AI? And you have any thoughts or any suggestions for those who are actually doing it in AI in an enterprise environment, or anything you want to share to our community?
A few thoughts. One thought that the first thing that comes to mind is that I do see a lot of trends of people chasing trends, and so AI has become, it's got the crazy buzz again, and the hype cycle is up again. It has multiple hype cycles, and this has certainly been true in healthcare. And one of the things I find myself repeating in lots of meetings at Athena and to other companies in healthcare is that that we're not selling AI. A lot of people are like, what can we do with AI? How do we use AI? Or like, what AI thing are we going to build? And this goes back to an earlier topic that we were discussing, that it's got to solve a business problem. We're not, athenahealth doesn't sell AI. And I don't think it should try to sell AI. And so AI is a tool for solving business problems. It's not, well, at least not for athenahealth. It's not a product in and of itself. It's not at this point. Maybe they'll pivot or offer a new line of product specific to healthcare AI. Who knows? But that's one recommendation is seeing past the hype and seeing that AI is still a tool. Ultimately we're still making decisions about how that's used and where to use it. And so the task becomes, how do you effectively use it to solve a business problem? So at the end of the day, it's still business. It's right. The same business. Processes and questions are relevant. You just have like a lot more tools that you can draw from to use it. As far as like tracking trends, there's always AAAI. That's sort of more academic, and so you're going to see like sort of the cutting edge stuff, but things that are probably pretty far out from being able to be applied. But there's a lot. When you say AI, people often think about these sort of voice assistants like Siri and Cortana and Alexa, and those definitely have AI in them, but it's pretty straightforward stuff at this point. So I'd say expect those things to improve dramatically as they tap into it. So there's a lot of solutions to make those things a million times better than they are now, and it's just a matter of time to develop those solutions and for those teams to crack into the academics and figure out how to do it and work with teams like that. So those things will improve dramatically over time. It will be interesting to see if they fundamentally change how humans interact with computers and with technology. So there's a guy named Chris Nocell who published a book just recently on agents of technology. He has some really interesting perspectives, and so he's actually already thinking about how do people interact with AI, with products that have AI. So he's an interesting guy to follow. If you want to check out his book, and then for applied stuff, I follow KDD, and there's just so many different things to follow, and great resources out there. Obviously, you can always follow me. I sort of throw things out there when I can, admittedly fairly negligent about my blog, but try to throw out things that I talk about and different trends and thoughts I have in the industry.
Interesting. So again, thank you, John, so much for sharing with our community your startup journey, your perspective on putting together a data science company, and then your thoughts on the best hires and your thoughts on the state of AI with respect to where the enterprise is. And definitely we'll be posting your Twitter handle so people will be able to follow you, talk to you, and if they need any clarification on it. And thank you so much, by the way, for candidly walking us through and sharing your perspective. Love to have you back at some point discussing about your second startup, and wish you nothing but luck in that. And thank you so much for spending time with us.
Sure. Thank you so much. Thanks for inviting me. It's been a pleasure.
I thought I was sick of home, but actually I was homesick. Never really knew that I would have to grow up so quick. I'm so uncomfortable, don't know anybody here. Just a couple dudes that I met once, that's it. And I go into the booth feeling nervous. Got butterflies in my stomach like I'm so worthless. Is the mic on? I don't know how to work this. Inside I'm breaking down, I hope I'm not up on the